Hey, athletes. In this video, we're going to look at radical division. Radical division will be more difficult than radical multiplication. And usually, let's just think of fractions for a second. Like multiplying fractions is easy peasy because we just multiply numerator with numerator and denominator with denominator. But if you think of division of fractions, well, it's a little bit more complicated because what we need to do is we take the reciprocal of the second, and then we've got to multiply from there. So it wasn't significantly more difficult, but we just had an extra step. And it's the same idea with division of radicals. There's just going to be a little extra step that we need to figure out. So like I said, multiplication was fairly straightforward, but division, we got a little bit more to do. First thing we're going to talk about is something called rationalizing. What rationalizing means is this. In general, we'll be asked to rationalize in 20-1. So what that means is we don't like to write radicals in the denominator. So what we'll do to get rid of the radical in the denominator is we're going to change how this looks, not what it's equal to. We're going to multiply by something very sneaky. The only number I can multiply by that doesn't change the value of this thing is 1. Right? Anything times 1 stays the same. So I'm going to multiply top and bottom by 1. Well, wait a minute. That's not doing anything. Okay, so I'm going to multiply by 1 in a sneaky way. And I apologize, I'm going sideways here. I'm going to multiply by 1 in a sneaky way. You ready? I'm going to multiply by root 2 over root 2. Because root 2 divided by root 2, anything divided by itself is 1. What do I get? 1 times root 2 is root 2, and root 2 times root 2 is 4, square root of 4, and the square root of 4 is 2. So that's how we're going to rationalize. We'll rationalize by multiplying by 1 in a sneaky way. We'll multiply numerator and denominator by the radical that we see in our denominator. Now, the reason why we rationalize is simply this, because there was a time, yes, there was a time before people had calculators. And 1 divided by root 2 is a really difficult thing to estimate. But root 2 divided by 2 is actually a really much easier thing to estimate. So before they had calculators, they would actually have a big table of square roots, and they would look it up, and they would say the square root of 2 is 1.414. It's irrational, it goes on forever. So they would say it's approximately 1.414 divided by 2. So it's approximately 0.07. That's it, friends. The only reason we still rationalize is because there was a day and age when people didn't have calculators. Now, that might seem silly to you that we're still doing it. I 100% agree with you. However, the government tells me that you must be able to rationalize a denominator. So guess what we're going to do? We're going to rationalize these things. Okay, now let's do some division. Divide the following and rationalize all denominators. Okay, so the first thing I'm going to do, very similar to multiplication, I'm going to say, can I divide anything? Well, can I divide my coefficients? No, 2 and 5 don't divide or simplify. And I've only got one radical. So on the first one, there's actually nothing to divide. So all we're going to do is rationalize. So we multiply by 1 in a sneaky way, just like that. And so this will be 2 root 3, and then 5 times root 3 times root 3 is the square root of 9, which is just 3. And so what I end up with is no radicals in the denominator, and I end up with 2 root 3 over 15. So nothing to divide on that one, just to rationalize. Next one. So the first thing I want to recognize on the next one is, can I divide? Yes, I can divide. Look at this. I can divide the 8 and the root 2. So let's do it. Root 8 divided by root 2 is 4. And the square root of 4, the kids tell me, is 2. And 3 times 2 is 6. There it is. Now, what if you hadn't recognized that you could divide right off the bat? No big deal. Let's do it again. What I'll do on this one is I will rationalize. So I'm only going to multiply numerator and denominator by the radical. I don't care about the coefficient of 7. When I'm rationalizing, I'm getting rid of the radical. So it's 3 root 16. 8 times 2 is 16. 7 root 2 times root 2 is root 4, which is 2. And then look at what happens. Root 16. Root 16 is 4. 3 times 4 is 12. 7 times 2 is 14. And guess what? We end up in the same spot. Which one was easier? Probably what I've got in blue. So always check to see if you can divide first before you start trying to rationalize. All right, a couple more. Now, these are the most difficult ones. So these are the ones you should put the star beside. These are the ones that students usually struggle with the most. So I'm going to rationalize this one, but this time because it's a binomial in the denominator right here, what I'm going to do is I can't just multiply by root 3 because that's not going to get rid of my radical. I'll end up with a 4 root 3 if you did it in the denominator. That's not going to help me. So what we'll do, amigos, is we will multiply by a very special term that I told you you needed to know in the last video called a conjugate. Why? Because what did the conjugate do for us? It got rid of all of our radicals. That's why it was so important. So again, that's called a conjugate, where everything is the same, but the sign in between is flipped. Okay, now all we do is multiply, friends. So we distribute like this. So it'll be 4 root 3 plus root 3 times root 3 is root 9, which is 3. And then here, we're going to distribute again. So we go 4 times 4 is 16. 4 times root 3 is 4 root 3. Negative root 3 times 4 is negative 4 root 3. And negative root 3 times negative root 3 is negative square root of 9, which is negative 3. Again, here's the really important part. Do you notice the two middle terms go to 0? They cancel. And do you notice, again, we've got no radicals. Here's the other thing I really want you to notice. Let's go hot pink. 16 is 4 times 4, or 4 squared. And 3 is root 3 times root 3, or root 3 squared. There's a shortcut here. You don't even need to show me these middle terms. Let's just worry about what happens with the first term and the last terms when we multiply them together. It's a nice little shortcut. I don't need you to show me the middle two terms. If you would like to, hey, that's fabulous, but you don't need to. There it is, my friends. Notice no radicals in the denominator. Okay, last one. So what I recognize is this is a binomial, so I need to multiply by the conjugate, like this. And this time I'm going to save myself some time in the denominator. All I'm going to do is I'm going to say, what's root 6 times root 6? 6. What's root 2 times root 2? 2. And it will always be negative because we're always multiplying with conjugates that have different signs. How much quicker is that? A little bit. And now let's distribute the numerator. So we get root 30 minus root 10. And so what do I get? Well, that's root 20 over 4. No, it's not. I'm just kidding. Remember, you can only add and subtract radicals if the radicands are the same. Don't do that, okay? There it is. And the last thing I'll say is, can I simplify either of the root 30 and the root 10? No, that's as far as it goes. There's that one. Okay, so that's the thing that usually students struggle with a little bit in 20-1. It's when we have to divide with a binomial. Now, I just want to show you one more thing here. So say you did a question and you had divided, you had rationalized, and you were left with something like this. So 4 root 6 minus 8 root 2 over 8. I want you to simplify this further. This isn't completely simplified. What you're going to do is you're going to say, can I simplify this? Is there something that divides into all three of my coefficients? Is there something that's a factor of all three? Sure, 4 is. That would then divide all of those by 4 like that. Okay? Please, 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 you cannot, have never been able to, your entire life, ever been able to do this. Okay? You can't divide those things. You can't, because I agree, 8 divided by 8 is 1, but it's not dividing into this coefficient. It has to divide into all three. And the other thing, let's try and get in the habit of saying the word divide and not cancel. Cancel means there's nothing there. 8 divided by 8, if you happen to be able to do it, is 1, right? 8 divided by 8 is 1. That's not cancel. Cancel means 0. 8 minus 8 is 0. That's canceling. Additive inverses, okay? Let's try to use the word divide. That's just me. Okay, friends, there's division. See you next time.